A tangent is a straight line that touches the circumference of a circle at a point. In this tutorial, we are going to look at tangent properties of a circle. This is Kisembo Academy, and thanks for tuning in. Looking at the diagram on your screen, you see a line AB. This line AB is touching this circle at a point X. Now this line AB touching this circle at a point X is what we are calling a tangent. Tangent, we said, is a straight line that touches the circumference of a circle at a point, and that is the point we are talking about. This line is touching this circle at that point X. So today let's get to explore more tangent properties of a circle. When we are having a tangent like this one touching just a part of the circle's circumference, if this is the circle's center, then the line drawn between the circle's center to touch the circumference of the circle, which is the radius, is going to make an angle of 90 degrees with that tangent. In other words, when the point of contact between the tangent and the circle will be making an angle of 90 degrees with the radius. We have some other properties that we need to explore here. Consider two tangents. We have BT here. BT is a tangent. And we are also having AT. It is also another tangent. These tangents, when they meet the circle at these points, they connect with the circle at a point whereby they make 90 degrees with this radius. So it means that this is 90 degrees and that is also 90 degrees. So when you realize that, as these tangents make these 90 degrees with the radiuses of this circle, they are going to make these tangents also subtend angles at the center. We have angle Y here and an angle Y there. The line that is joining the center of the circle to the common point where these tangents are meeting outside the circle, this line bisects this angle. And by bisecting, I mean that it's going to divide this angle into two. So this line that is connecting these two tangents from the circle center to the point where these two tangents meet outside the circle divides this angle into two. So meaning that if this angle is X, this one is also X. Likewise, this same angle is also going to divide this whole angle into two. That is why you see that when this is Y, that is also Y. So this is how it is explained in our write-up, that length BT is equal to length of AT. So if you look at this tangent BT, the length from here to here is the same as the length from here to there. Angle BTO, which is this one, BTO, which is that one, is the same as the angle OTA, which is that one, because this line bisects this angle into two. It bisects this angle, so it divides it into two. So if we are having this line being equal to that line, we are having, this is the radius of the circle. It is equal to that radius of the circle. So these two are the same. These two lines are the same. Then you're having this angle being equal to that angle. And then you're also having this angle Y being equal to that angle Y. It simply tries to mean that this right angle triangle is the same as that right angle triangle. And as such, this middle line we are talking about is simply acting as a line of symmetry. As we proceed, we'll be interpreting some of these numbers using some of these properties. If you look at this number, we are being required to find the value of Z, the value of X, and the value of Y. Now, we know that these ones are tangents. And you know that when a tangent is going to meet a circle, the radius, the angle between the radius and the tangent is 90 degrees. So by that knowledge, we already know that the value of Y here is 90 degrees. And the value of X here is also 90 degrees. Now what's the value of Z? There are two ways you can find the value of Z. First of all, this is a quadrilateral. This. And we all know that a quadrilateral, the total angle sum of a quadrilateral is 360 degrees. So it means for us to be able to get the value of Z is going to be X plus Y plus Z plus 35 degrees is equal to 180 degrees. 360 degrees. So it means that's our working, that Z plus 90 plus 90 plus 35 is equal to 360 degrees. We make z the subject of the formula. It becomes 360 minus the rest of all this comes that side. And we get our value of z as 145 degrees. Now we can either get it like that, or we can choose to use another way. It means using our property before, we can choose to divide this into 2. Remember, we said that this acts like a line of symmetry. This is a right angle triangle, and this right angle triangle is the same as this right angle triangle. We said that this line bisects this. It means it divides this angle 35 into 2. So if it's dividing it into 2 equal parts, so if this was originally 35 degrees, dividing it into 2 means that this is going to become 17.5, and this one is also becoming 17.5 degrees, these two angles. So it means that this value of z is also being divided into 2 equal parts, into this and that. So if we are to extrapolate this right angle triangle here, and we are to say that we have extrapolated this, so our value of y here is 90, which is this part, 90. So this is our value of z. It has been divided into 2. Let's call it theta, our value of z. Then our value 17.5 is up there. So if you are to get 17.5, now our task is to find the value of z. But you know that to find the value of z, we can first get the value of theta. We know that when we get theta, we will multiply this value of theta by 2, so that we get the whole value of z, since the value of theta here is the same as the value of theta the other side. So to get this value of theta, we know that this is 90, and we know that the total angle sum of a triangle is 180 degrees. So this is simply going to be theta plus 90 degrees plus 17.5 should give us 180 degrees. So if it is to give us 180 degrees, it means our value of theta there is simply going to be 180 degrees minus all this, minus 90 plus 17.5. And we shall get our value of theta as, now 72.5 is just half of that value of z. We want the whole value of z. So it means that for us to get the whole value of z, it means that z is going to be 72.5, multiply that by 2. And when you multiply that by 2, you will end up with 145 degrees. We have another example to work out here. We have, this is a tangent, that's also a tangent. We are required to find the values of q, the value of r, and the value of p. Now, straight up, from here we know that the line that is connecting this center of the circle to the point where these two tangents meet, it divides this into 2, or it bisects this angle. So if it's bisecting this angle according to our earlier property, it means that the value of q and the value of r is the same. Likewise here, this angle is also being bisected, or it's being divided into 2 equal angles. So if this angle is 82 degrees, it means that the value of p is also 82 degrees. So straight away here we know that the value of p is 82 degrees. And now what about the value of q and r? We know that this being a tangent, it meets this at that point at 90 degrees. If it means at 90 degrees, it means that we shall take interest in just one of those triangles. And we know that the total angle sum of a triangle is 180 degrees. So it means it's going to be 90 degrees plus 82 degrees plus r is equal to 180 degrees. So it's 90 plus 82 plus r is equal to 180 degrees. So our value of r is going to be 180 degrees minus 90 plus 82. And we shall get our value of r as 8 degrees. So when we get the value of r as 8 degrees, it means that even our value of q will be 8 degrees, because this value of q and r are the same. We can try and find the length of the tangent d.